Hey guys, Cooley here. I'm going to give you an update on what's going on with the magnetopause and what's actually happening right now as we speak. I'm going to do a little bit of a review for you here, just for a second. Okay, now um, we're getting hit again with some energy from the sun direction. Okay, um, there's going to be a whole lot of talk here of where this is coming from. I do think that a coronal hole is the main cause for this particular event that we're seeing right now. And I'll show you what I mean here in a minute. But I do also think that these other magnetic sources are affecting all of this. Okay? I think it's making it more intense. I think it's making it, I don't know how else to put that. Um, it's making it stronger than what I typically would have expected from an event like this. And there's a whole lot of factors there. Okay, we got to factor in the weakening of our magnetopause and our shields together. I mean, we have to factor that in. Okay, and why are we weaker? Well, because the sun is in a minimum. Okay, so we have to always take that in consideration. So it's not going to take as much of a hit to affect our magnetopause and to see it react like I'm getting ready to show you. Okay, this looked like a pretty hard hit. And if you remember my previous video, remember I said we can look at this number right here for solar wind, and we can. Okay, this gives us captures every 4 minutes. We can go over to space weather, and you can see it gives you a solar wind by kilometers per second also. Okay, but this seems to, I don't know how to put this. It's more frequent. It updates it more frequently. So we see a whole lot more. So the fluctuation, and I don't know where the data is coming from, if they're both getting the data from the same source, or if they come to their solar wind speed by other means. It just doesn't seem like the space weather one ever gets as high as this one. So I mean, I've seen the space weather one get up close to 800-900 before, but this one here seems to fluctuate more. So whether it's just updating more often or it's more sensitive, I don't know. But what I'm going to do is I'm going to show you, because this is a good way to show that this thing fluctuates. Okay. So what I've done here is, and this is going to be the most recent. I mean, you can see the timestamp down here at 7/7 at 1400 hours, which would be 2 o'clock, yesterday morning. Okay. Well, afternoon. Sorry. And then what I've done, it goes back 300 captures. So it started from real time while I'm making this video, and then it goes backwards. But what I want you guys to really pay attention to, because it's not going to be hard to see this thing in here just getting all crazy. But you got to watch this number. Okay, so when you see something crazy on this, look over here on that, and you'll notice what I'm talking about. Okay, I'm going to just do that real quick. Okay, so I mean, all that right there isn't that big of a deal, right? I mean, it's not reacting that much. Now, I will say this too. This is something else I've noticed. The past few days, our bow shock out here is really, really thick. Okay, it's large. What do I mean by that? Well, the distance from here to here is wider than what it normally is. Okay, normally that's a pretty thin line. It's not real thin, but it's normally a lot thinner than that. So that tells me that that's heat getting built up right there, and it's in a larger area, is what I'm trying to say. And something else too, this whole area right inside this is also experiencing more intense pressure. Okay, and that's behind our shields. So that's rather large right there. We don't typically see this green that well defined this large. I just wanted to say that. Now, does that mean a whole lot of anything? Not unless something gets through, right? I mean, it's just something that we just kind of take with a grain of salt. Now, you're going to see these little waves come through. You see how it gets orange in the front? Then you see our bow shock start to fluctuate like wings flapping, right? It's compressing. Okay, we're getting hit with some energy there. And you can just about gauge that every time we get hit there, our solar wind speed may go up just a little bit. Okay, but what I find interesting here, now you see that big one, right? See where the wind speed went? It's at 370. Now, and we even went to 380. Now back here, it was at 352. Now I seen a 400 there too, so we'll see where that's at. See 431. We just had a wave come through. You see that? So, and then there's a bigger one. Now you're probably not going to see a fluctuation in the solar wind speed until it hits the bow shock. I think that the satellites that it's seen or detecting that are kind of further back. Now you see that it's getting ready to spike to 4. Now that was a decent hit. Okay, 4 something there, and then we're getting hit with waves now. Now you see the 476. Okay, now you're seeing, like I said, obviously, guys, you can see how this thing's reacting. And something else I'm going to point out, we don't typically see this either. The buildup of this red color right here on the back. I mean, that's intense. Okay. We really shouldn't be seeing those kinds of things. And that's something that, I mean, we do see it sometimes, but when we do, it's a rare thing to see it like that, is what I'm trying to say. Especially if you compare it to what's in the front, which is virtually none. That's why you got the light blue color. Usually, this thing is the same color all the way around. It may vary or lighten up going towards the back or the front, but typically you don't see those difference in colors right there. Again, we did get hit with a wave there, and it's probably because of this coronal hole. And again, I have to say, I don't think the coronal hole is causing all of it, but I do think it's contributing big time to this. Now you see this, right? This is why I'm doing this video. Okay, I just want to give you guys an update because this is happening again. You see this? See the wind speed there? 590. Okay, we're going to go compute that here in a minute too, and I'll show you. But I want to go through here because it gets higher than 590, guys. Okay, now you see how we remember what I told you in previous videos? We compress like that, and then we do rapid expansion. You see that? It's just the Earth trying to protect itself. Okay, and it's doing it. Now look at that. Okay, now you're seeing intense. Even right here in the front, you see this just building right there. I mean, that is just, it's amazing to see that. Okay, I'm going to back it off so you can see it more. Now you see that? That's hardly any pressure in the front. We go from that to that within like a half hour. I mean, that's just crazy. So anyway, and you see these darker blues starting to show up, which is virtually no pressure. Now look at there. Look at the wind speed. 729. Okay. Now, if this happened the other day without having a coronal hole, I would say this would be a malfunction of the tool, because the waves we were getting there were coming from a different source, and we knew it because the sun wasn't doing anything. Well, now we have to actually factor this in, so that actually could be a correct number. I'm not saying that it is. I'm just saying there's more of a chance that it is. Okay. It's probably a little bit of both, guys. But at this point, I mean, look how our magnetopause reacts. You know, 5 years ago, and I've said this before, we get hit with a wind like that, it's probably not going to react this bad. It's going to react, and it's going to react big if you get a 729 kilometers per second wind. It's just going to, okay? But this here looks pretty severe, is what I'm trying to say. Alright, now you're seeing that just going off, and you can see how, and my guess is, guys, that this is just going to keep up. We're going to get some waves on and off all day long. That's just my guess. Now, again, like I talked before, we have to take in consideration, guys, that this can affect our chances for larger earthquakes. Okay? That's really the main thing here. I mean, we could have satellite disruptions. We can talk about that all day long, but that's just an inconvenience. That ain't massive destruction and people getting hurt and killed. Okay, that's more important than any of that other stuff. Okay, So this is the same time frame, but I'm going to show you a couple different things here. You'll be able to see the waves really good on this one. Okay, you can see them coming in, and you see that. I mean, some of this stuff is really, really odd to me. These are signatures that I've not seen before. The shapes of them is particularly what I'm talking about. Now you're seeing this line out here is basically the borderline of our shield. Okay, so when you see that thing move and compress in, you know that's where our shields are at, right? But you can also gauge by the colors there too and the shape of it. Now see those waves inside there? I mean, look at that. And again, we've seen this before, but I don't want to become complacent, and just because I've seen it before doesn't mean that it's not important to talk about. Okay? So, here we go. Now you're seeing it move. Now remember the line I just showed you, okay? That thing is doing some crazy contortions. Plus we're getting build up of pressure on the back there, okay? All this is coming. We're bouncing around in that. Look at that. That was at 434 UTC. Our shields, this is the satellite line. Okay? It may have dipped in to our satellite line there a little bit, because we get captures every 4 minutes. So we don't know what happened in between those captures. So it could have dipped in there for a minute. If anything, it's awful close. And we got lucky in the aspect. Now check this out, guys. There's other satellites orbiting other than just the GOES 13, 14, and in the comms. Okay, those are the three that this thing charts. But we got lucky in the fact that these satellites are back here right now. If these satellites were here in the front, we probably wouldn't be getting any data from this. Okay? It would affect that. It's done that before. They shut down, they go into safe mode. I mean, I've talked about that a lot. But you see how far that compressed in? Okay? It compresses in, and it did it rapid. Okay? I'm going to show you. That's at 433. Okay? That's at 434. 1 minute. Okay? They don't usually do this. This is what's strange to me. Okay? These are supposed to come in 4-minute increments. Why did all of a sudden this tool just do it in 1 minute increment? Alright? See, if you look here, it says 433. Then it goes to 430. Okay, that was 3 minutes. Why is this not staying on its 4-minute capture? It did that time. Did they see something they didn't like, and they wanted to update this thing a little bit more quicker than what it was doing? And they did like a manual override and said, hey, give me almost some more data. Okay, is that what's going on here? I don't know. All I can say is that was just 1 minute between that and that. So how do you go from that to that in 1 minute? That's what I want to know. That's huge. Completely huge. How does all that pressure go away in 1 minute as we compress? Now the next capture, you're going to see it. You can see the Earth pushing back. You see that? It's going to do its rapid expansion. I bet this next capture, it shoots out pretty far. Sure enough, there it goes. Okay. And then we get that. Okay, it's pushing back, and then it'll bounce back. It's just what it does. Okay. Now you see something else I have to point out. You can see the Earth pushing out in all directions. Okay, it ain't just pushing out in one direction. It's pushing out in all directions. Okay. So these are some signatures that I've not seen before, like the shape of these inside of here. You know, used to before when we got backside pressure, all you would see would be a little arc back here. Even though it was inside the satellite line, it was still just a little arc, but we're getting these really elongated shapes. And, you know, I have to say that I think it's because of the other magnetic sources affecting us. I don't think this is all solar wind. Okay? Now, like I said, I do think the solar wind's having a great influence on it right now. Okay, you see see how the Earth just pushes out in all directions magnetically? That right there, as fast as that moved. Okay, we go from that to that almost being flat, and then boom, that in 8 minutes, 4 minutes, 3 minutes, whatever it was there. Man, I just don't know. I mean, I would be more apt to say that was like a flare that we got from the sun, but I went and looked and I couldn't find any. Okay, at least for this timestamp. Now the one yesterday I found some. So, anyway, I thought that was really, I mean, and then I'll just show you the same thing here. This is just the lines of magnetism. Shows our connection to the sun, our polar lines, and our closed lines. The blue lines are our connection to the sun. They're called IMF lines. Interplanetary magnetic field lines is what they stand for. Okay, if anybody was wanting to know that. Now, this is pretty symmetrical. This is what I was trying to show the other day. This is actually kind of normal. Okay, you see these lines? Pretty symmetrical. In a perfect world, they would be like this. Okay, but we know it's not perfect. So, this is pretty typical. But what you're going to see is when we get hit in the front there, it's going to be like a ladder. Okay, remember Chevy Chase in Christmas Vacation? He's up on top of the ladder, and the ladder gives way, and, basically it looks like he breaks all the rungs on the way down, like an old cartoon. Well, Chevy Chase just actually kind of slid down. But, I mean, you get the idea. These lines get broken in that way. You'll see what I'm saying when I run this through. Okay? Oh, shoot, I didn't load that up. Sorry. Anyway, yeah, that was not cool. Let's go ahead and load that up real quick. How about that? Okay, I'll hit apply there. While that's loading, we'll go back over here and we'll take a look at this. Okay. Now, again, like I said, guys, I do think that that this has something to do with that coronal hole, and it's increasing our solar winds. So, with that being said, let's let this thing load. It loaded already. Cool. I'll go ahead and pause it there. Okay. Now, I'm just going to drag it, okay? But you're going to see, now watch the blue lines, how they split. You see that? See how they went from pointing that direction to the other? That's because we're getting energy. And if you look out in the front, we're tilted down magnetically. We see that quite often. I think it has something to do with our connection to the sun. And we do sit a little bit south of the sun's equator. So that may have a little something to do with it. But I don't know if it's supposed to be that drastic. Okay, now you're seeing these little waves come in, right? I'm calling them little, but they're not really all that little. Okay, boom. Okay. Now, when we get to the timestamp of 4:34, you're going to see, I'm guessing, you're going to see something kind of crazy. We're at 3:38. Okay, yeah. See how red that got? Look at that. Okay. I mean, we're getting. I mean, that's pretty intense, guys. I mean, it just doesn't get any more intense than that. And then it hits our bow shock, and it goes around, then it compresses us. Look at that. Just like I showed you before. And see, we push back, rapid expansion. Okay, and then see all that heat build back. All right, and then currently we are right here. So, that is what it is, but yeah. So what I want to do, guys, is I'm going to show you guys something here real quick. Let me close all that out. Now, I have a converter like I showed you guys before. I think I showed it in my last video. Kilometers per second to miles per hour. 729 is the kilometers per second is what we've seen there, right? Now, this is going to put it in perspective of how fast this is moving. It's moving at 1.63 million miles per hour. Okay, you divide that by 93 and you get your amount of hours, and you can get a time frame of when this would reach Earth. Okay, and that falls right into the 3 to 4 day thing I was talking about. So yeah, now I'm going to take you guys over here to this model, because this shows it pretty well too. This is an Australian model. Scott had sent me a link to this one. It's pretty cool. Basically what it is, it's just showing you our shields. Okay, now you're seeing it bounce around, right? You see the bounce really well on this one. Okay, I'm gonna go back to the 7th, and we'll hit play. Okay, so yeah, see how that bounced almost into the satellite line? You can see the satellite line there, right? Now I'm gonna go to the 8th, and I do know that I'm gonna pause it. Okay, now let's go forward, because I know the timestamp number. Alright, that's at 2:44. You see how close that's coming? This should be hanging out here. Okay, so when it gets compressed in there like that, we're getting pressure. Alright, and again, this is taking it in 1 minute increments. That's what this model does. That's at 2:45. You see how close that is? Okay, then the next minute, that's how far it goes back out. Okay, and you're seeing it bounce around here. I'm just going to hit play again, I guess. Alright, again, we'll go ahead and watch it again. And then it does this. Watch, here it comes. Boom. You see that? I mean, when it does that, that means it compressed in pretty well. Okay? So, yeah. I mean, let me show you this real quick. This will kind of give you a little bit perspective of what I was talking about with the coronal hole. This was part of one of my last videos. Remember I posted this? Earth-facing coronal hole. Okay. Increased solar winds expected by the 8th to the 9th. If you look down here, this is when I took this capture. The 5th. Okay. This right here is causing some of what our problem is. Okay. Now I also have to say that we did see that little sunspot down here give us a couple small, I have to really say that, flares. Okay. It's indicative when you see these flares. If it does one of these numbers, they call it an X flare for this reason. Okay, it actually looks like an X. Okay, now you'll see little hash marks on these little arms. It's just what the camera's picking up, or the tool's picking that up. That's how it's visualizing it for us. Okay, now whether it looks like that for real, I'm not really sure. But when we see this signature like that, that's when we can call it an X flare or a flare. We did see that. We seen that signature, but it was really small and happened twice on a sunspot that just basically just came out of nowhere. All right. When they talk about a blank disk, they're talking about looking at this sun from the SDO or stereo A, and they don't see any sunspots. Okay. When they don't see any sunspots, they call it a blank disk. It's just terminology that they use. They don't actually think that the sun's a disk. Okay, I've heard people say that before. That's not what they're saying. Okay, all they're trying to relay there is that there are no sunspots when they say a blank disk. I'm just saying that because I want people to understand this terminology, because it helps people understand this whole thing in general. So, and why don't we have any sunspots? Well, solar minimum. Okay, that's why. Hence, that goes back to our magnetic field weakening here on Earth, because the sun's magnetic field is weakening. All right, keep that in mind. The magnetic field of the sun encompasses our whole solar system. Okay, so when we see energy that we don't think is coming from the sun, It could be coming from outside of our solar system. It could be coming from inside. Um, like we've been talking about the Planet X object. All these different magnetic fields that are surrounding this. There are so many variables, guys. So when we can't blame it on the sun, we have to find something else to look at to see if that's where it's coming from. So, that is what it is. And unfortunately, they don't give us the tools to be able to, show people what's really there. We catch it every once in a while, and we do show it to you guys. And that's why we do what we do. But, just kind of keep that in mind. I just wanted to give you an update because I do think that does make the earthquake risk greater. Now, we did have another 7.1, I think it was, over in Indonesia. And the pressure's still building up in California. Go watch Dutch Sense's last live stream. They had a couple like mid-range, like 3s over in Oklahoma and Texas. So he was explaining to people that some of that pressure may have been released over that direction, but it wasn't big enough to get rid of all of it. And, he's really thinking, I'm not sure if he's thinking this exactly, but I think basically what he's saying is if we get another big one in that area, it's going to be bigger. We're talking 7.5, 7.6. And when you talk about going up a half a point, okay, the difference between a 6.5 and a 7 is almost 100% increase in intensity. So if you go from 7 to 7.5, it's at least that. It's more, actually, probably. Okay? And not to mention that these things are shallow. So, the stuff is moving when we start having these earthquakes over there. I think we had was it 42 or 4,500 different earthquakes in the past day. So, that is what it is. But that is something that we really have to pay attention to. There's a lot going on, and I think that, to leave out what's happening in space weather would be a disservice to all of us. So we have to pay attention. No matter where this energy is coming from, I'm just trying to show you guys that this is a possibility, and this is definitely influencing what's hitting us right now, this coronal hole, okay? I'm not saying it's all of it, but it is some of it, okay? And again, we sit just right below the equator, okay, when we're orbiting the sun. So when these things come around and we connect magnetically or what have you, we keep that in mind too. So, this sunspot that did the X flare was kind of like right there. And it's rotating in. The sunspot's still there now. It didn't go away. It's still there. And it's a small one. I don't know. It doesn't even look very active. It might be a little active, but it's not. And don't get me wrong. If we get a flare off of this thing, another one, I don't look for it to be huge because the sunspot itself just isn't that big. But the fact that we even had a flare just come out of nowhere where there were no sunspots yet is a bit, well, I don't want to call it rare, but it's something out of the ordinary. Normally there's an active region when we start seeing these things, and sometimes they call them coronal prominences. They're larger areas of activity like this right here. That, if you guys remember, when it was over here, that was really, really active. It was really bright. It was doing a bunch of filaments, and the filament didn't release. Okay? If the filament had released on out, it would have been a coronal mass ejection. That would have been a CME. So when these things start rotating Earth facing, that's really when we perk up. But this sunspot that's down here right now, and it's rotating in, if it decides to get bigger or more active, we have to keep in mind that not only are we having increased solar winds, but our shields, again, they're weaker. So if this thing fires off a flare right at us, it's going to affect us more. And that's my whole point to this. I just want everybody to be aware that, we're still getting hit with this energy, and no matter where it's coming from, we can talk about that all day long. The fact of the matter is, our magnetopause is being affected. Okay, so people have to pay attention to the things that are caused by that or influence that, such as the bigger earthquakes. Okay, so anyway, I just wanted to bring you guys up to speed on that, and I do think we're going to get more and more waves here in the next couple days. This today, maybe tomorrow. I'm not sure exactly how long this will last. I'm not sure how long this stayed Earth facing. My guess is about a day. So we'll probably see effects from that for about a day. I mean, that's just my opinion. But again, we have to watch this one sunspot, the only sunspot, as it rotates, to be even closer to Earth facing. So anyway, guys, God bless. Yeshua saves, and you can drink this Kool-Aid.